Now we'll see how to create or delineate the watershed using the Hydrology toolbox. So for this we don't need all these files. Let us open a new workspace. Let's just save this. Yes. So Watershed delineation. Let us close this. Let us add the TM again. Open our toolbox. Now we'll use the Hydrology toolbox. So multiple tools are available here. We'll be using some of them and we'll see how to create a or delineate a microwatershed. So first we have to use this fill tool. It will fill if any gap or some issue is there. So let us create one new folder here. Hydrology. We'll keep all our data here as we'll be creating multiple layers. So first is fill. Once it is completed, let us use the fill one. I'll remove this one. Now we'll create the flow direction map. Use we have taken the input. Now output direction. We'll be using this D8 method. This flow direction type D8 method will be using. You can check the flow direction, how it looks. For different color, different angles. It is denoting different your colored pixel. Now we'll derive flow accumulation. Here you can see it is asking to add the flow direction raster. So here we will take the flow direction and output will just rename this again accumulation. Again, this will not change this method unless there is a mandatory your change option will not change the method or output data type. Click on OK. You can see it has highlighted the stream network. If you want to highlight more stream network, you can change this minimum maximum values. So I'll just right click and go to properties. I change this to minimum maximum and reduce the maximum values. More stream will appear as white color. Just 10,000. Now you can see these streams has appeared. If I reduce it to 5,000, so if I take 5,000 as my maximum flow direction for this white colored pixel, so any values more than 5,000 will be in white color, and you can see multiple streams are now visible. So now we have to now identify the streams. So for that we have to take this flow accumulation raster and we'll use this map algebra tool. Now if I write flow direction more than, let's say let us take this 5,000. If we take more than 5,000, it will create a stream. Now output raster will be flow accumulation reclass. It will reclassify the data into 0 and 1. So values more than 5000 will be 1 and less than 5000 will be 0. You can see like more than 5000 are only these your network. So you have to repeat this process again. Now we'll take, let's say 1000. Let's see, declassify, I will say 1000. So you have to optimize this particular threshold value based on the level of stream you want to generate. You can further reduce it to 500. I think that will give us better stream network map. I think this is much better. We'll use this. Just remove the other stream network. And based on the ArcSort toolbox, as you know, our Microwatershed we created in this part. So I will add a point here. The outlet point I will define here, and I'll compare the automatically delineated watershed with my manually delineated microwatershed. So the next step will be creating a point shape file to delineate our outlet. So for that I need to create a sync. No, I'll create a point shape file. Hydrology, click new, shape file, outlet I will define, import the projection from this field DM. Now the outlet is added here. Right click here, I'll add the editor. The editor is not available here now. I'll add, maybe I can also add 2 points. Make sure that you are adding point along the stream, otherwise it may not be able to identify or delineate the watershed. So be careful. You have to add the point on the stream. Once it is added, click on save edit and then stop edit. Okay. This watershed delineation toolbox, let us close this here. Once these outlet points are defined, let's click on this snap over point. Input point feature is the outlet. Let's just open the attribute table. In ID both are 0, so we have to edit this. Let us keep it 1, second one is 2. Go to editor, save. Why this is opening again and again, and then stop editing. Close this window, open this snap over point. Click on the input raster of point feature. So we'll use again this outlet. Now we have added the ID and you have to choose the flow accumulation raster, this one. will give me a raster basically. Outlet snap.img. Let me add this. We'll just found 2 pixels are added here. This is 1 pixel and this is the other pixel. These are the 2 outlets. Based on these 2 outlets, our watershed will be delineated. Now go to Hydrology and click on Watershed. Include flow direction, input raster point. This is our outlet snap. Then watershed.img. Let's check the output. Yeah, you can see our watersheds are created based on these 2 outlets. I have to just convert from raster to vector. I'll go to conversion tool from raster. These are polygon, raster to polygon. I will take from raster watershed values to Microwatershed's hydrology. Here you need not to define the extension. It will automatically add the .ssp extension. The simplified tool, if you want to simplify the boundary, you can use this. Otherwise, if you uncheck this, it will create the boundary based on the pixels. So, depending on your choice, it upon on choice. Click on OK. You just add the watershed. Yeah. Now let us compare the watershed which we have created manually. Is the one. Yeah, this is looking more or less similar. And uncheck this one. Let us also add the output from our ArcGIS. Just check. Just keep it down. Just assign a different color here. It is nearly same. In all other areas it is same, excluding this part. Some minor changes is there. So this may be due to difference in the outlet point. Maybe in the other one, in ArcGIS, we took outlet here, and in this case I think the outlet was here. Depending on the outlet position, it has modified this part, but the rest of the portion, the Microwatershed delineated using Hydrology tool or ArcGIS is same. There is no change. You can see there is no change. Yeah. I will now stop here and thank you for your attention.